Hello, everybody. My name is Ashley Wong. I'm an engineer at solo.io. I work on the Gloo team. So today we're going to be talking about Traefik, which is a cloud-native edge router, in other words, an API gateway. So a quick note, I'm going to be pronouncing it Traefik, even though the official pronunciation I think is Traefik, because everybody I know calls it Traefik, and I don't want to overload terms. Cool, so a quick refresher. An API gateway is an API management tool that sits between a client and a collection of backend services. So an API gateway will act as a reverse proxy to accept all incoming requests or calls, route them to a set of rules, and return the appropriate result. So here we see the Traefik homepage. The company that creates it is called Containous, and we're just going to go ahead and get started. So here it says what sets Traefik apart, besides its many features, is that it automatically discovers the right configuration for your services. The magic happens when Traefik inspects your infrastructure, and it finds relevant information and discovers which service serves which request. So this service discovery is a pretty common feature of API gateways, and is definitely something that is a reason why a lot of people use API gateways. Cool. Another thing to note is the credo for Traefik is deploy and forget. So let's go ahead and get started. We're going to do a quick start example, which is a simple use case using Docker. So I've already created this docker compose.yaml file. Right here. As you can see, it's going to be using the Traefik version 2.2 Docker image, and we're going to launch it using Docker Compose up. So let's do that. And it's started up, good. If we open a browser and go here, we see that it already has some metadata. So now it says Traefik detects new services and creates the route for you. And the new service that we're going to deploy in Docker is going to be a who am I container. Who am I essentially echoes back to you like your IP address and some additional information. So this is going to be started up using this command. Let's do that. And it has started up, good. So now if we go back to our browser and look at our API raw data, we should see that Traefik has automatically detected the new container and updated its own configuration. So let's go here, refresh, and boom, you see that it has some additional information. All right, now we can actually do a curl request and see if this new route has been created. So we ran the curl command to our local host, and we see the output of the who am I command. Great. So another common feature of API gateways is load balancing. Load balancing is when you have multiple backend services and the incoming request can be routed to either of them. One way to do this is to scale up the who am I container, which is done with this docker compose scale command. So let's do that. And done. We're going to go back here and see that Traefik has automatically detected the additional thing, and it has. Great. Now we're going to run the curl command twice. Once and twice. Okay. So if we go up, we can see that the first time it hit the .0.3 IP address, and the second time the curl command hit the .0.4 command IP address. So this is, I believe this load balancing method is called round robin. Round robin is when it hits like each backend service in order, and when it hits the end, it goes back to the very beginning. Cool, so that if we do this a couple more times, it's going to just alternate between the .0.3 and the .0.4. And that is load balancing. Great, so we're going to talk a little bit about how Traefik is configured. And in order to explain this, we need to learn a few terms. One of these terms is providers. So a provider is an existing infrastructure component. One example could be Kubernetes, one example could be the file system, one example could be the Docker use case that we used or saw in our quick start example. So the idea is that Traefik will query the provider's API in order to find the relevant information about routing. And each time Traefik detects a change, it dynamically updates the routes. So here's a list of all the providers that Traefik can use. One way to see which provider that your Traefik command is using is if we actually look at our docker compose.yaml here, we can see that the arguments passed into the Traefik binary are .api.insecure and providers.docker. This providers.docker command argument is telling the Traefik binary, hey, you should query the Docker API in order to look at any services being created, any services being deleted, and any changes like that. This API.insecure thing is a security thing, not safe in production, but it's good for a demo. Cool. And here's the complete list. Next, we're going to quickly talk about routing and load balancing, because there's a couple more terms we need to learn here. So let's zoom in on Traefik's architecture. A couple terms, let's just, the definitions are here. Providers, we've already talked about. They discover the services that live on your infrastructure. The next term we want to learn is entry points. So these entry points will listen for incoming traffic. They're basically equivalent to ports. So port 443 could be your HTTP secure port. Port 8000 could be your normal HTTP port. Next is routers, which will analyze the request. They can look at the host, the path, the headers, or any SSL information, and use that information to route to the correct backend service. Services are going to forward your request to whichever services, and here you can do load balancing. And then finally, there are middlewares, which can update your request or make decisions based on your request. You can see a full list of them on the left here. Basically, these are operations that can do additional authentication. They can do rate limiting, or they can change your headers, like doing replacements of words or regex. Cool. You can, if you want to learn more in detail about these terms, here's the docs for them. But we're going to go ahead and go to our user guides. So the case that I'm interested in is Kubernetes. I have a Minikube set up already, and I'm going to try to go through this user guide. Traefik and CRD and using Let's Encrypt. So this should be secure because Let's Encrypt is a way to do SSL. A quick note, so Traefik can use multiple providers, as we talked about before. We ran through a quick start with Docker as a provider. A lot of the examples here will use the file system as a provider. And if you go here, one of these is the Kubernetes Ingress Route as a provider. This means that we're going to be using custom resource definitions in order to provide our configuration. So quick background, CRD is an object that extends the Kubernetes API, and it's something that you can define. So it's a very commonly used way to provide information. Go back to the user guide. In this example, they use the K3s Docker image for Kubernetes cluster setup. I'm going to go ahead and use Minikube because I already have that set up. So we're going to skip this section. And let's get my Minikube version. And it's all running, so should be a clean install of Minikube. So first, we need to actually apply a couple CRDs. Here's the Ingress Route and middleware CRDs. See here. And this is the name, Ingress Routes. These are going to be specific to Traefik. So I'm going to copy this. Great. So all of these new CR custom resources have been applied. Additionally, there were several RBACs applied. RBACs are role-based access control. It's just a way to manage permissions. Nice. Then we're going to apply some services. One is going to be for Traefik itself, and one is going to be an app. So based on our quick start Docker example, this is going to link to the Traefik binary, and this is going to link to the whoami service. So that's done. And next are deployments. So these are going to be the actual pods that run the code. Well, so you can quickly look and see they exist. They're not quite ready yet. If I check again, I'm sure, yeah. So the Traefik pod and the whoami pod, they're all ready. So quick note, if you actually look at the arguments being passed into this Traefik binary, again, we're using the image with the version 2.2. We have API insecure, that's fine, we're running a demo. And then here, providers.kubernetes CRD is telling Traefik that, hey, we're running in Kubernetes, we should be talking to the Kubernetes API. And again, by the way, we're running 2 replicas of the whoami service, so we can do load balancing. All right. Now, as an exception to what we said above, please note that you should not let the Ingress Route resources below be applied automatically to your cluster. The reason is as soon as the ACME provider of Traefik detects that we have TLS routes. Okay, this is a security thing. So we need to delay applying the Ingress Route resources, which are down here, until we have port forwarding set up properly. All right, so these ports, I believe, are mentioned like up here. So, something to do with like so we're going to be exposing these ports, I believe. Okay, cool, let's do that. And port 8080 is already in use. Let's check what's using that. Oh, okay, so yeah, our Docker things are still running. So cool, so that should clean up. And now this port forward should work. Okay, so now we're all set to move forward. All right, now we can actually apply the ingress routes. This seems to be the last step. Yeah, I think this is what we want to copy. So what this ingress route is doing, it is pointing to the entry point web. It's, oh, okay. So I'm going to replace your.example.com with localhost, because I don't actually own your.example.com. So let's do that. And let's create, hopefully that's big enough, pv paste. So that has created our 2 new ingress routes. Yep, and we can look at the YAML. Route TLS this way. And we can see that we're using localhost here. Cool. I'll give it a few seconds. I believe this is for the security thing to run. And first, let's go ahead and try to curl the localhost without the TLS. So we expect for this to route to the who am I service in the backend with no expectation of any certs being provided. Let's do that. And yep, we get the who am I service and we get the results. Next, we're going to try to curl it on the TLS route. So this is curling the TLS route. And it hits the service and it went through this ingress route. Cool. So that's what we have. We see it routing in Kubernetes. Let's take a quick look at the logs. So kubectl logs. We want to look at our Traefik container. I'm doing a -f. Okay. Yeah, this is what the logs were going to look like. Unable to obtain a CME certificate. That's probably because I don't have a Let's Encrypt staging server. And that's the reason why I had the -k here. What this -k does is essentially skip past the security stuff. But as you can see, here's the curl command when I ran the curl/no TLS. And this was probably written when I did the curl command -k for the TLS route. You can test that here. If we copy this, curl here, yep, and we see it logged again. Another way to monitor it is, I believe, since we're already port forwarding 8080, Traefik has a dashboard at localhost 8080, and it looks like this. Here's a list of all the entry points. The 8080 port is going to be called the admin port. That allows you do some like API calls. There's port 8000, port 84443. I believe you can see these here. So these are the ports that were exposed. And here they are as entry points. Additionally, we can see the routers are here. We have 4. They're all successful. Here's our TLS one that we created with our Ingress route. Here's our no TLS one. If we go back, here's our services. There are a couple ones that like exist by default. And then here's our TLS, Ingress Route TLS, simple Ingress Route services. I don't believe we added any middlewares, so these are default ones. Additionally, we had no TCP Ingress routes, and we had no UDP Ingress routes, although they do exist, and you can look at them if you see our CRDs. So if we take a look at the Kubernetes CRDs that Traefik provides, this is the one we were using in our Kubernetes example. There's another one that's very similar called Ingress Route TCPs. And there's another one called Ingress Route UDPs. Cool. Here, so the general setup flow, I think, for using Traefik in Kubernetes is first, you're going to have to apply the Traefik CRDs, which are defined here. Next, you're going to apply the RBACs, which should also be defined here, except at the bottom. Yeah, these RBACs, which are permissions. And then to configure it based on your own services, you will have to convert your services. First, they're going to be Kubernetes services. Then you can potentially wrap them in these CRDs called Traefik services. Here's a couple examples. Let's go ahead and apply them. So here we've created a couple of Traefik services and a couple Ingress routes that will route to these. We also have a TCP example and a UDP example. Let's take a look at the logs. Logs. Okay. So hopefully you can see this. If there is an error while building a Traefik service, because the Kubernetes service is not found, then it will create a log line here, and it will look like this. It also has the provider name and the service name. That makes sense because we did not actually create a Kubernetes service, so these are pointing to nothing right now. Cool. So I'm going to now talk about my general impressions about Traefik. First, I believe it's pretty lightweight. It's pretty easy to get started with, especially since if you look at the configuration introduction / here, one of the ways that you can actually get started with Traefik is using the file system. And if you look at some of the configuration examples here, there's some pretty good documentation, and all of them are using the file provider. Another note is a lot of the global configuration for Traefik is done using TOML, YAML, or arguments passed into the Traefik CLI. The one that I've seen most often is arguments passed into the Traefik CLI. Quick reminder, they're the ones that look like these command arguments. So if you are coming from a background that's very familiar with YAML configuration or TOML configuration, then Traefik should be pretty easy to pick up. One thing I was thinking about when I was going through this was I was a little bit worried that if I learned Traefik using these file provider examples, I was wondering how easy it would be to kind of modify that configuration and put it into a Kubernetes environment. So if I start out with services and I configure them using TOML, how easy is it to turn this into a Kubernetes CRD? Like I would have to change it into a YAML format, figure out which Kubernetes CRD to put that YAML into, and then apply it into the Kubernetes environment. So it would be really nice if there was like a very quick script to convert this this like configuration from one provider to another, especially if I want to migrate my system from, say, a Docker system to a Kubernetes environment. Quick note on security. So in Traefik, they support HTTPS and TLS. In our Kubernetes example, I believe they had a way to automate using Let's Encrypt to provide certificates for each route. This is done using the ACME provider. If you don't want to use Let's Encrypt, then there are other options. You can provide your own cert file and key file. And I believe at the very bottom, they say you can do client authentication or MTLS. So that is possible. Final note, it seems that in comparison with Gloo, Traefik uses slightly encourages users to keep all of their configuration in one place. So for their global configuration, it's a lot easier for the user if they put all of the configuration all in CLI arguments, all in a TOML file, or all in a YAML file. Another example is if we look at our Kubernetes CRDs. I want to see an example of an ingress route. So this ingress route is, I believe, very similar to the Gloo's concept of a virtual service. In this ingress route, all the information is in one place. So you have the routes, what they match to, we have priorities, we have what they should route to, which can be either a Kubernetes service or a Traefik service. The load balancing information should be in here as well. And all the authentication information should be here as well. So this is all in one place. Whereas in Gloo, we have a lot more abstractions, such as route tables, upstreams, and auth configs if you're using Gloo Enterprise. So that's just a slight difference. And final note, I do believe it is possible to route to gRPC services. If we go to our user guide, wow, yeah. There is an example of how to route to a gRPC application. Cool, with that, I'm going to wrap up. This was our third in our series of API Gateway videos. And thank you for watching our 10th episode of Hoot. We're in the double digits. We've got a couple more of these videos on our solo.io YouTube channel. And if you're interested, please check out our Slack as well. It's our solo.io Slack. Thank you very much for watching and have a good day.